All right, so basically we started with this on Friday, um, where we went through working examples of a of area. Okay, but I just want to quickly explain this to you in detail. So this was basically to show you how to draw it. So you're going to draw a rectangle. So in order to find the area of a triangle, the formula for it, you draw a rectangle first. You can use 5 and 3 centimeters, doesn't matter how many. Okay, you draw a diagonal through the middle. So you're going to draw a diagonal through the middle. So that means you're going to split the rectangle in half. And that is going to create the two triangles. So you're going to have triangle ABC and triangle ADC. And then from there, we are going to determine the area of the rectangle ABCD. Okay, so what is the area of ABCD? What's the area of a rectangle? Length times breadth. But now what we've done is we've actually split them up into triangles. So we've halved the rectangle. So in order to halve the rectangle, we've now got half of the area, which is length times breadth. But we can't say length times breadth for a, okay, so this is basically what I explained now. So we can't have length times breadth for a triangle, okay? We actually need to have the bottom of the triangle and the height of the triangle, how tall it is. Because remember, that is to do with the 90 degrees that is connected to the triangle. Okay, so this is where we're getting the half from. The half from is because we cut the rectangle in half, and the area of the rectangle is part of this. Okay, so what's going to happen now is the height, which is 3, and the base, which is 5, gets multiplied by half of the rectangle. Okay, so that is actually how we get the area of a rectangle. So we've got area of a rectangle is half base times height. So it's basically like saying it's a rectangle's formula, but just cut in half. Anyways, so different types of triangles. You're going to get something that looks like this. So it's not going to be a right angle triangle. It's actually going to be a triangle that has a right angle or a height on the inside of the triangle. So make sure that you don't get confused where the height is. The height is when it is connected to the little perpendicular box. I want to say square, but it sounds a bit weird. So basically, the base is when it goes all the way through. So it's BC is the base, and the height is AD. Okay, so it's basically right from the right angle height of the triangle. And you can see the height doesn't always look the same. It can also be turned upside down, all those kinds of things. Okay, then you're going to get this one here. We'll get a right angle triangle. This one's a bit easier. So we've got our base at the bottom and our height over there. But sometimes you can actually swap it around. Luckily, when you are using these formulas, you are using a lot of multiplying. So it doesn't matter where you put the base or the height, as long as you put the correct number in. Okay, just as long as you don't use the line that is opposite this right angle, because that is not the base and it's not the height. Remember, it's always connected to the little right angle. All right, just a quick question. If we look at this big triangle here, so DEF, what is the base of DEF? Triangle DEF. What is the base and what is the height of DEF, the big triangle? Okay, so our height can be DF and our base can be EF, the bottom there and the top there. Or you can say it's the other way around. DF is the base and EF is the height. But now, if I'm looking for the base of the mini triangle here, okay, let's look at the little triangle. What is my base? What is my base over here of DGF. What is my base? My base is GD, so this bottom part here, just that little bottom part. And then my height is GF. The same as if I look at this little triangle here. Do you see that there's a 90 degree here? 90 plus 90 gives me 180. So that means that that's also going to be 90 degrees. Why? Because it's on a straight line. Straight lines are 180 degrees. Okay. And my base is GE. And my height is GF. Okay. Cool, 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 cool. Moving on. Then you get these weird triangles. Weird triangles is in like, there is your triangle here. It's a bit more difficult. This is your triangle. And then this is your height of your triangle. So if I'm asking you for the base of your triangle is the bottom of your triangle. So there's your 90 degree. Carry it on. And you see that here is actually where your triangle starts. So then it carries on until there. That is your bottom of your triangle. And then your height will actually be here. Okay. Same thing here. Bottom there. There's my bottom. There's my height of my triangle. Cool. And then that formula. Right. So this is in your books. And we are starting with example 1. Consider the following triangles. So write down all these for me, please. Make sure that you have it in your books, and then we will write down the answers afterwards. So consider the following triangle. Calculate the perimeter. So the perimeter of your triangle that you're looking at here is your actual triangle. So what I suggest you do is you take a color and you highlight just the outside lines. So the actual triangle is the 13, the 10, and the 19. This is not the triangle at all. Okay, it's dotted. So that means it's a construction line. It's not really there. Okay. So the perimeter is when we're adding all of the outside lines. So it's going to be 13 plus 10 plus 19, and that's going to be our perimeter answer in centimeters. Calculate the area. Now this is where we're going to use this line. So we've got our bottom of our, so we've got half. Yeah, area equals half times the base, which is 10, and the height, which is 12. Okay, so half times that, so let's say half times 12. Half times 12 is 6. Or half of 12, sorry. Half of 12 is 6. And then 6 times 10 is 60. So it will be 60 centimeters squared. Okay, so there are our two answers. Okay, so after we've written down all these questions, you write down the answers in. All right. In triangle ABC, the area is 48 meters squared, and the perpendicular height is 16 meters. Find the length of the base. So they've given you the area, and now you need it, and they've given you the area and they've given you the height. So now you need to find the base. So what's going to happen is you're going to type in this formula, put in the area that they've given you, and put in the height. They give you the height. Put in the height that they've given you. So if you look, we have got 48, half, and the base. So we don't know what the base is. So let's rather go, what's half of 16? Half of 16 is 8. Then what we're going to do is we're going to go 48 divided by 8. Why? Because there's a multiply there. So to get rid of this, we actually need to divide. Okay, so what we do to get rid of this is we're dividing by 8 to get rid of this 8. But what we do to this side, we do to this side. Right. So we're going to get 48 divided by 8, which is 6. So my base is 6 meters. You have to say meters. Don't say meters squared because we are looking for the base, not the area. Okay, and the last one is use the formula to calculate the area of triangle ABC. Okay, so now you need to find the area of triangle ABC. We've got the base and we've got the height. Okay, so it's half times base times height. So half of 18 is 9. So 9 times 6 is 40. No, what am I doing? 54. Did I say that right? Yeah. Anyways, 54 centimeters squared. You can just write that in. I didn't put it in here. So you just write example 2, and then you are going to write out the formula and then plug in the area will be, let's just use this one as an example. So this one will be 18 and then this one will be 6. So then it will turn into 9 times 6, which is 54. All right, and then converting units. So when we are converting units, I suggest that I actually took this and I printed it out so that they have it at the back of the books, but you need to read over this. This is for your sanity. So to go from kilometers until meters, you're going to hop back. From meters to kilometers, you hop to the front, but you are dividing here. So like I said, it kind of sounds weird. If it's bigger, you have to make it smaller. So it's difficult to understand, yeah. But use this as your guide. This is the easiest way to actually convert everything. If you remember this, you are golden. Okay. Yeah, pretty much. Then remember you are converting from centimeters to meters, but then you are now, when you are doing area, you are starting to convert between centimeters squared to millimeters squared. So now instead of multiplying by 10, so if you look here, from centimeters to meters, millimeters, we multiplied by 10, right? So we multiplied by 10. Whereas now from centimeters squared to millimeters squared, we're taking that 10 and we're squaring the 10. So what's 10 squared? 100. So we're going to go times 100. So let's do the same thing here. From meters to centimeters, we times by 100. But now because we are squaring it, we're doing area. What's 100 squared? 10,000. So that's why we multiply by 10,000. So that you need to just keep in mind. Okay. Yeah, and then this, copy this into your books. This is an example of what it will look like if you have to convert. To convert from 1 centimeter squared to millimeter squared, it's basically like saying how many millimeters will fit into 1 centimeter, and then just doing the same area formula. Yeah, and then example 2, you copy it down. All you're doing is you're basically writing down the question, which is that one, example 1, and then you're writing down the answer. And then you write down the question, you write down the answer. What I suggest you do is maybe put this in another color. So if you want, you can maybe write this in blue pen and this in black, or the opposite way around, however you want to do it. If you use a color, just be very careful. I'd be very careful what colors I use. This one is a bit more different. So here you can actually see there are 2 different ways. So you can either multiply it like that, where it's in decimal form, or you can use fraction form. Either way, you'll get the same answer. Just remember, if you have it in fraction form, you have to turn it into a decimal form, which some of you might struggle with. So that's why I would stick to decimal form for you. Then for the last thing, I want you actually to do this for me. This is your classwork. This is what I need you to answer by yourself. So basically taking things, changing it into different measurements, making sure that you understand that. And then the last few are when you actually get shapes. So then you have the shape that needs to be changed into the lengths. I think, yeah, 2 sides of a triangle are 2,5 centimeters each. Calculate the length of the third side if the triangle's perimeter is that. So they give you the perimeter, they want you to find the other sides. So that's normal, perimeter, what's it called? Normal perimeter question. And then number 4, This one is combining basically your conversions and your area. So it says that you have a diagram that shows a rectangle divided into a triangle and a trapezium. So there's your triangle there, there's your trapezium here, and there's your whole rectangle. Calculate the shaded area. So this shaded area, the trapezium, you need to find out how much that is going to be. And they've given you the measurements in centimeters but your answer needs to be in millimeters. So what I suggest you do is you change your, well, in my opinion, just because it's easier, change that first. So change your centimeters into millimeters first. Or what you can do is you can find the answer and then change your answer from centimeters squared to millimeters squared. You just need to keep in mind the conversions. But yeah, so that is it for that section. And after this, it is surface area and volume. So that is what we will be doing this upcoming week. What's the date? I can't remember. Anyways, so yeah, that is what we're going to be doing. And you can actually get a net of I think it's a rectangular prism. Otherwise, it's a cube. You're going to find that online, and then you can build that yourself. And that is basically investigating what's it called? Surface area. Yeah. Okay, cool. Bye.